Welcome back to the Deep Dive. Today we're going into the surprisingly high-stakes world of automated environmental monitoring.
We are. And we're doing it through the lens of a single, pretty specific piece of hardware.
Exactly. We have one source, the datasheet for a commercial sensor. And our mission, really, is to shortcut your understanding of how this small device becomes a silent sentinel for, massive enterprise infrastructure.
We're looking at remote facility protection by focusing on just one input, sound.
And the sensor is the NTI ENLS noise level sensor. It's not expensive, maybe $150. Its core job is just to sit there and measure sound, decibels.
But the value isn't in the listening. It's all in the reaction.
Right, so it provides the input, but it can't do anything by itself.
Not a thing. It's fundamentally dependent on a larger brain. It has to plug into an RJ45 sensor port on an NTI Enterprise Environment Monitoring System.
Okay. The E2D, Nation 5D, or the NIDA 16D models, according to this.
That's right. The power, the intelligence, everything comes from that core unit.
So the true value is really in the configuration layer. The sensor feeds it raw data, but the main system is the one making the decisions.
Absolutely. The system is the crucial piece. It takes that raw noise data and then it reports on it. Or, more importantly, it sends out alerts when noise levels go above or below thresholds that you set.
So it's not just a volume meter. It's an early warning system.
It's exactly that. You could set a high threshold on a factory floor for safety, but you could also set a really low threshold in a server room.
Oh, I see. So if the noise floor suddenly drops to zero.
Right. That could mean a critical HVAC unit just died. The absence of sound becomes actionable data.
That's a huge shift in focus. Okay, let's drill into the specs now, because the system is only as good as the measurements it's getting. What's the measurement range we're dealing with?
It covers a pretty robust range from 33 to 116 dB, but what's really important is the response type. It's A-weighted.
A-weighted.
Right.
So for our audience, what does that actually mean?
It basically means the sensor is designed to hear things the way the human ear does. It filters the noise to mimic our perception of loudness.
Which makes the data immediately useful for, say, employee comfort or OSHA compliance?
Exactly. It's immediately relevant.
And what about accuracy? I did see the source mentions a bit of a variance there.
It does. It's plus or minus 3 dB for the 1 kilohertz frequency, but that widens to plus or minus 6 dBs across the whole spectrum.
So for super precise acoustic work, that's a trade-off you have to consider.
For sure. But for general enterprise monitoring, where you're looking for a significant change in the noise level, this is more than reliable enough.
Okay, and connectivity is where this starts to scale, right?
Yeah.
It's a standard RJ45 connector, CET5 cable, up to 1,000 feet. That's a decent start.
Good baseline, yeah. But here's where it gets really interesting for, these vast facilities.
Okay.
It's also compatible with the EFSE fiber converter.
So that completely changes the game on distance.
It blows it wide open. You can extend the sensor up to 1.2 miles. That's 2 kilometers away from the main unit.
So you could be monitoring a remote utility substation from a central office miles away.
Exactly. Or buildings on a huge corporate campus where running copper just isn't an option.
And one last detail here for the procurement folks listening. The source says it's TAA compliant. That's a critical detail.
A very critical one. It means the sensor is made in the U.S. or a designated country. For anyone doing government or defense contract work, TAA compliance is, well, it's non-negotiable.
Right. Okay, so let's unpack the lesson here. This deep dive really shows that a simple, $150 noise sensor is just the first link.
In a highly structured, automated chain, it's turning the passive ambient sound of a building into its vital signs.
Yeah, that's a great way to put it. So that leaves us with a question for you to mull over.
If these specialized sensors can turn simple noise into actionable security data over a distance of more than a mile,
what other seemingly minor sensory inputs, beyond just noise or light or vibration, are now being quantified
and used to dictate how our facilities protect and operate themselves completely automatically? The ability to measure is fast becoming the ability to command.